There's a $2 device that can generate electricity continuously. No fuel, no monthly bill, no connection to the grid. No, it's not magic. It's basic physics, the kind you were taught in school, but never shown how to apply as a complete system. And that's the real story here. The problem isn't that this technology doesn't exist. The problem is that you've never been taught to see it as part of a working energy system, one that you can actually build, scale, and control yourself. In this video, we're not just looking at a cheap trick. We're breaking down how energy actually flows through the natural world, how modern energy systems are designed to monetize that flow, and why the simplest solutions almost never become standard. Because once you understand this, you don't just save money on electricity, you start to see the structure behind every energy system, and more importantly, how to step outside of it when you need to. Welcome to Hidden Systems. Long before power lines stretched across continents, humans didn't produce electricity the way we think of it today. They harvested energy directly from their environment. Flowing water turned wheels, wind powered mills, and sunlight drove heat and motion in simple, elegant ways. By the 19th century, early inventors began experimenting with small-scale electrical generation. These weren't massive power plants. They were localized systems, often built by individuals, converting natural energy into usable electricity right where it was needed. No grid, no centralized control, just direct interaction with physical forces that already existed. But something changed. Electricity slowly shifted from being a phenomenon you could tap into to a service you had to subscribe to. And once that shift happened, it required infrastructure, generation stations, transmission lines, metering systems, all designed not just to deliver power, but to measure and bill it. That's how the modern grid was born. And here's the key insight. Once energy becomes centralized, any decentralized solution, no matter how simple or effective, stops being just an alternative. It becomes a disruption, not because it doesn't work, but because it doesn't fit the system built to control and monetize energy at scale. To understand why a simple $2 device can feel disruptive, you have to look at how modern energy systems are designed. Today's grid is a centralized system. Power is generated at large plants, transmitted over long distances, and distributed to end users. Every layer adds cost, complexity, and dependency. And each layer must be maintained, regulated, and paid for. That's why electricity arrives as a metered service with a recurring bill. But that structure isn't the only way energy can work. A decentralized approach flips the model. Instead of moving energy across vast networks, it's generated right where it's used. No long-distance transmission, no multi-step distribution chain, no need for continuous metering. The system becomes smaller, more local, and often more resilient. This is where the $2 device fits in, not as a replacement for the entire grid, but as a building block in a different kind of system. Because once you generate even a small amount of power locally, you begin to change your role. You're no longer just a consumer, you become a participant in the system. And that shift from passive user to active node is what truly challenges centralized models. Now let's ground this in physics. No device, no matter how cheap, creates energy out of nothing. What it does is convert energy that already exists in the environment into a usable electrical form. And that energy is everywhere. Sunlight carries electromagnetic radiation from the sun to the Earth's surface. Temperature differences create thermal gradients between materials exposed to heat and those in shade. Air movement transfers kinetic energy through pressure differences. These are not rare phenomena. They are constant ambient flows of energy happening around you every second. A small device simply acts as a transducer. It converts one form of energy into another. For example, when there's a temperature difference between two sides of a material, electrons begin to move. This is a well-documented physical effect studied for nearly 2 centuries. That movement creates a voltage. Connect a circuit and you have current. The key insight is this: energy doesn't need to be delivered to you. It's already present. What large-scale systems do is capture, concentrate, and redistribute that energy in controlled ways, and then charge you for access. But at a smaller scale, with the right understanding, you can tap into those same flows directly. Now let's talk about numbers, because this is where expectations need to be grounded. A single $2 energy device is not going to power your entire home. That's not its purpose. On its own, it might generate anywhere from a few milliwatts to a few watts, depending on the energy source and conditions. That's enough to run LED lighting, small sensors, low-power electronics, trickle charging for batteries. But the real power of this system isn't in one unit. It's in scaling. Energy systems, even at industrial levels, are built by combining small units into larger networks. The same principle applies here. 10 modules produce 10 times the output. 100 modules begin to form a micro-scale energy system, and once you start thinking this way, the question shifts. It's no longer, can this replace the grid? But, what portion of my energy demand can I decentralize? Even offsetting a small percentage matters. It reduces dependency, lowers costs over time, and increases resilience. In systems thinking, this is called modular expansion, small, repeatable units that grow into a functional system. And that's where a $2 device stops being a gadget and starts becoming infrastructure. If systems like this are so simple and grounded in basic physics, why aren't they standard in every home? The answer isn't a single conspiracy. It's system design and incentives. Modern energy infrastructure is built around large-scale investment. Power plants, transmission lines, grid maintenance, and billing systems all require massive capital. To sustain that, the system depends on predictable, recurring revenue. Electricity isn't just energy, or it's a service model. Now compare that to a small decentralized setup. No subscription, no metering, minimal maintenance, no centralized control. From a systems perspective, it doesn't integrate well, not because it doesn't work, but because it doesn't align with how the current system recovers costs and generates profit. There are also regulatory layers, building codes, safety standards, installation requirements. These are designed for reliability at scale, but they tend to favor established, centralized solutions over small experimental ones. So the reason you don't see this everywhere isn't that it's impossible. It's that the dominant system wasn't built to prioritize it, and what doesn't fit the system rarely becomes the default. The right way to approach this isn't as a single device, but as a small, functional energy system you can assemble step by step. Start with the source. Identify what energy is most available in your environment. Sunlight, heat differences, or movement like wind or water. You're not forcing energy to appear, you're choosing which natural flow to tap into. Next comes conversion. Use a small, low-cost module designed to convert that specific form of energy into electricity. At this stage, output will be unstable and variable, and that's expected. So the third layer is stabilization. A simple voltage regulator or control circuit ensures that the electricity becomes usable for small electronics. Without this step, most devices won't run reliably. Then add storage. A small battery or capacitor allows you to accumulate energy over time, smoothing out fluctuations and making the system usable even when the source is intermittent. Finally, connect low-power applications, LED lights, sensors, or small charging tasks. What you've built is not a replacement for the grid. It's a parallel layer, a microsystem that reduces dependency, increases resilience, and gives you direct control over a portion of your energy. That's how systems evolve, not by replacement, but by addition. The most important takeaway from this video isn't the $2 device. It's the shift in how you understand energy. Once you realize that energy is constantly flowing around you, in light, heat, and motion, you begin to see that the grid is not the source of energy. It's just one way of organizing and distributing it. And that changes everything, because it means you don't have to disconnect from the system to gain independence. You just have to reduce how much you rely on it. Even a small, self-built setup gives you partial control, and that control compounds over time. This is how real system change happens. Not through one breakthrough invention, but through many small, distributed decisions made by individuals. Layer by layer, dependency decreases, flexibility increases, resilience becomes personal, not centralized. You don't need permission to start building that, you don't need approval to understand how energy works, and you don't need to wait for the system to change before you do. If this perspective gave you something new, share it. Because ideas like this don't spread through infrastructure, they spread through people. This isn't just about electricity, it's about learning how to see and redesign the systems around you. Welcome to Hidden Systems.